Hello students, good morning and welcome to mathematics class. Today we will start a topic chapter 1, that is real number, and brief introductions about the real number we will do. Real number we have two types, rational number and irrational number. Look here, rational number means any number given in the form of p upon q, where this q should not equal to 0. And if we can write p upon q, then it is called a rational number, and if we cannot write in the form of p upon q, it is called a irrational number. All you understand? Now rational number can be divided, can be separated into format. Okay, so rational number we have, first is terminating decimal expansion, and second is non-terminating repeating decimal expansion. Look here, terminating decimal expansion means the decimal, we will change the fraction in the form of the decimal, then it will terminate, means it will end. We will get the remainder is 0. When we divide, we will get remainder 0. Means here, look here, you have 5.37, this is a terminating. 0.7325, this is also terminating. Look here, 2 upon 5, 3 upon 10, 7 upon 2, these all are the terminating decimal expansion. Look at this, 2 upon 5 and 3 upon 10 and 7 upon 2, when you will change in the form of the decimal, it will terminate format. Okay, so you can divide and check. Next is non-terminating repeating decimal expansion. In this format you have this 75, 75, 75, this is repeated, and non-terminating means you have dot dot dot. Okay, all you understand, means it will never end the decimal expansion. Okay, so this type is called non-terminating repeating decimal. Here look here, if you have some questions here that in denominator if you not have 2 or 5, 2 or 5 you have, means it is a terminating, but other than 2 and 5 you have, means 3, 7 and 13 you have in denominator. When you divide this 2 by 3, the decimal format will be non-terminating repeating decimal format you will get. Same as it is for 5 upon 7 and 3 upon 13. Next is non-terminating non-repeating decimal expansion. Here this format is called irrational number. Irrational number will when we change the irrational number in form of the decimal expansion, the decimal expansion will be non-terminating non-repeating decimal expansion. Means you can check here, we have 2 0, then 2 and 2 0, then 2 and 3 0, and 2 and then 4 0, means this again we get 2. Okay, so this is non-terminating and non-repeating decimal. Look here, you have root 2, root 3, root 7, 2 plus root 3, 5 plus 3 root 2 and 1 upon root 2 and pi. These all are called the non-terminating non-repeating decimal expansion, and these type of numbers are called the irrational numbers. So I think you clear the doubt about the rational and irrational number. All you understand this? We will do the exercise 1.1 here, and the special very important thing we will do today, Euclid division lemma. Euclid division lemma we have to understand. So look here, given two positive integers a and b, we are given two positive integers and a and b. For these two positive integers a and b, there exist unique integers q and r. For two positive integer, there exist two more positive q and r. Okay, two integers you will have, such that a equal to bq plus r. A equal to what is? bq plus r, where r is greater than equal to 0 and less than b. Look here, this q is called a quotient, and this r is called a remainder. All you understand? So here if we have this remainder is 0, means a equal to bq plus 0, then SCF of a and b is b. We have two number a and b. And if we have for these this remainder is 0, means we can say SCF of A and B is B. Look here, some example we will do here. So look here, if we have two numbers 13 and 3, 13 and 3 we have two numbers, and for the 13, look at this 13 we have to write in this form 3q plus r. Okay, and where this r will be greater than equal to 0 and less than b is what is here 3, so less than 3. Okay, so look here, this 13, how we get q and r, quotient and remainder we have to find here. So this 13 we have to divide by 3, 13 divided by 3, 3 4s are 12, 3 4s are 12, remainder 1. So this is r and this is q. So here this we can write 13 equal to 3 into 4 plus r is 1, and you can check this r you get greater than 0 and less than 3 you get. Look at place of 13, if you have 14, if you have 14, remainder is 2, remainder is 2. If you have 15 here, 15 means again you can write 3 5 are 15, means you get here remainder is 0. So look here, if I have here the second example, if I take here and if I number have 15 and 3, 15 and 3, then we can write this 15 equal to 3q plus r. Okay, and 15 equal to, we can write 3 into 5, 3 into 5 is 15 and r is 0, remainder is 0, and q quotient is 5. So here we can say that SCF of 15 and 3 is 3, because this 3 two numbers 15 and 3, and what is the SCF of 15 and 3 is 3, this is 3. Okay, so by this method, by the Euclid division lemma, you can find the SCF of two number also. So this is very important for your exam also. Look here students, we will use Euclid division algorithm to find SCF of 135 and 225. Look here, I will explain you the division algorithm. So look here, first of all we will write here this 135 and 225. Here A will be equal to 225 and B equal to 135. This 225 we will divide by 135, so it will divide by 1, so we get here 135, and subtract these we get 0, and here is 9, 90 we get here. Okay, then again we will divide here 135 we will write here, and this 135 again we divide by 9, 9 2 ja 18, we have more, so 9 1 ja 9. Okay, so we have here subtract, so we get here 45. Now 45 by 45 we divide this 90, so 45 2 ja 90, and remainder is 0. Now remainder is 0 means this SCF equal to we have to write 45. Now how we write the algorithm? We have to write the algorithm for these. We will write here A equal to BQ plus R. A equal to BQ plus R. A is here in starting we have 225. A is 225 and B is 135. Okay, and Q means quotient is 1 and remainder is 90. Now in next time with this 135 we can write equal to 90 into 1, and plus remainder is 45 we write. Now this 90 we write, 90 we are writing 45 into 2, and remainder is 0, and when the remainder is 0 means this B is a SCF, so this SCF is 45 we write here. All of you understand these SCF of, by this method you will find the SCF of 8, 67 and 225. Here we will get answer 51, and one more question you will do 196 and 38220, There here we will find the SCF is 196. Actually 196 into 195 and plus 0 will be equal to 38220. So here this remainder we get 0. So 196 is a SCF. All of you understand this? So that any positive odd integer is of the form 6q plus 1, 6q plus 3 or 6q plus 5, where q is some integer. Look here, by the Euclid division lemma, you can write here by Euclid division lemma, we can write here a equal to bq plus r, where r is greater than equal to 0 and less than b. Now you compare this question. Look here we have 6q, means place of b, what we can write here? Place of b we can write here 6. So you can write here, put b equal to 6. So look here, what we get, a equal to 6q plus r, where this r is greater than equal to 0 and less than, place of b we are putting 6, so here also 6. Now r will be equal to, what we can write r, from 0, 1, 2, 3, 4, 5 and 6. Less than 6 means we write up to 5 only. Now look here, these value we have to put here. So what we can write, a equal to 6q plus 0. 6q plus 0 is 6q. Then 6q plus 1, place of r we put 1. Then next 6q plus 2. Then 6q plus 3. Then 6q plus 4. Then 6q plus 5. This value we will put place of r. 6 is here even number, and if any number is multiple of even number, it is a even number. So 6q is a even number, okay. And if we add 1 in the even number, again it is a odd number, and one more add we will get a even number. Here this is a odd number, and this again we can check, this both are divisible by 2, so it is a even number, and this 5, so it is a odd number. Now in question what we have to do, so that any positive odd integer is of the forms 6q plus 1, 6q plus 3 and 6q plus 5. So odd integers are, you can see here, these are 3 are odd. So odd integer, it's so that odd integers are of the form 6q plus 1, 6q plus 3 or 6q plus 5. So these odd numbers will be only on these 3 format we will have.